Hello everybody, Chaz Large here with another Fix It video for you, and on the bench today we've got a Denon amplifier. Well, it's a Denon Tuner Amplifier, quite a nice one. I had one of these myself not so long back. Beautiful piece of kit. It's got CD, RDS and radio text capability built into there, but it's not a DAB one. It's just purely FM and AM. It's got lots of extra inputs on the back for lots of different features, such as CD, DVD and auxiliary, playback and record for tape, and playback and record for MIDI disc, and also got a subwoofer capability as well. It's also got a couple of system connectors there for linking it so the remote control can talk through to the other units, so you have one remote control that talks to everything. So this has come in to me with a fault that one channel is not working. In fact, it's actually got two faults. The second fault was an intermittent fault, which customer wasn't that worried about, but it'd be nice to fix it if possible, and that is that the volume control would sometimes not change the volume control. You could turn it, it's one of these rotary controls that just keeps turning round and round and round, so it's an encoder type control. But you'd be turning it and turning it and turning it, and no volume would change, and then you turn it again and the volume would change. So whether it's a problem with the encoder or contacts or whatever, we will find out as and when we get the amplifier part of it working. So let's give it a bit of a test. What I'll do is I'll take the lid off and get it into a position where we can actually test it, and then I'll come back to you. So roll the titles. Right, here we are with the lid removed. Basically 2 screws on the side and 4 on the back. 4, 5, 1, 2, 3, 4, 5 on the back. And we've got quite a good view. Now, I've worked on a few of these in the past. The amplifiers alone are much better to work at than the all-in-one systems where you have to have got different layers sitting on top of each other. These amplifiers themselves are actually quite nice to work on, apart from the fact they use surface mounted components. It's sort of like the crossover bit between the old good old-fashioned amplifiers with lots of sticky up transistors and things on it. This has still got some, but it's also got a lot of SMD devices as well. So on this part of it here, we've got the main power supply, nice big toroidal transformer there, output stage over there. That's just the remote control interface. The preamp and drive stage and output stage is all here, and whilst it looks awfully difficult to work on, actually it's quite easy on this particular one. Now, the first one of these I ever did, I thought, oh my goodness, how am I going to get all these wires trapped together? So I took the front panel off and various bits, undoing screws. Turns out you don't have to do half of that. All you have to do is remove 4 screws that are holding the heatsink to the chassis. That's these 4 here, 1, 2, 3, 4. Undo those 4, and the whole amplifier lifts up, and with that circuit board mounted, and you can actually flip it over with a bit of insulation in between so it doesn't short out, and you can actually work on both sides of the circuit board there and do various tests. Hopefully we'll be able to use that facility, but for testing purposes, to find out where the fault lies, we'll have a look at this. Let's first off have a look at the actual circuit. So on the circuit here, this is the main output stage, so all of this circuitry here is all on that panel, and we've got 2 pre-driver amplifier stages, op amps here in one package, so that's the one IC serving 2 sides. Then we've got the drivers here and here, just there, and then we've got the output stages which are here, and the protection circuits which as well. Now, one thing I can tell you is if you do get a fault with the output of these pre-drives, which changes the DC conduction. You remember, if you look at most of this, it's all DC coupled. Okay, so you've got DC connection through to those transistors, through down to there. It's balanced across two plus or minus 32 volt supply rails. So if you get a fault where this DC output of this op amp is really dynamically changed, this circuit here is just going to basically trip in and shut the whole thing down. So hopefully, that won't be the case in this respect. There'll be a fault that's basically just stopping the signal getting through. Fingers crossed. So we'll turn it on. Okay, and we've got on the front there, so let's go back to this, get rid of the circuit for a minute. So we can see there we're into auxiliary. The green light has come on, which means it's working. I heard a click of the relay, so the actual output stage is working. I know that because the relay won't click in until the output stage is working correctly. So basically that's where we've got to start. So I've got my wonderful piece of test kit here, which is an old phone with some music or test tones. So I've got a 1 kilohertz test tone. Let's play that, and not much sound coming out at the moment I can hear, so let's turn the volume up. Now you can already actually see this fault, the other fault that the customer complained of, is as I'm turning this, sometimes these numbers are changing and they're not going up. So it should go up to 90, I think, or max 60, 65. But you can see as I'm turning it, sometimes that number doesn't change and sometimes it does. So we'll come back to that. And there, it's a bit iffy at some stages. But we're definitely getting output on the right hand channel. So that's for sure, I can hear that. And we'll just double check it with the next piece of test equipment, which is a good old pair of headphones. So let's turn the sound up. The headphones are a lot less. So there's the tone off of one channel and nothing out of the other one. So we know that the output stage is working on one side of it. Let's unplug that again. Right, so we're definitely getting a signal through to it. We now need to determine where that fault is. So the best thing to do really in this case is do a bit of signal injection into the input. Okay, so what I'm going to do is I'm going to inject a test signal into it using my trusty dusty signal injector. It's basically just a little simple flip-flop circuit that I've mounted in this antiperspirant applicator, which I've used to hold a rechargeable battery. It's one of the old vape cells that I found lying on the roadside with a little charge circuit on there, and basically when I switch this on, we'll get a square wave coming out of there, but it's quite a high signal, I think about 2 volts. Now if we're going to apply this into this circuit here at this connector, there's no volume control. The volume control is on the previous part, so we're going to go right into the early part of the amp. So I'm going to be very tentative and just dab it quickly, because if I put it in there and overdrive the stage, I can cause more damage than what I cure. So pin 3 and pin 5 is the 2 inputs. 1, 2, 3, 4, 5. The fact that it's going into 5, 4, 3, nothing on 3. So the fact that we're not getting any output, I think we're going to have to say the fault is going to be somewhere on that IC. So let's have a little look at some voltages around that chip. So pins 4 and 8 should be the positive and negative supplies. So pin 4 is that one. Whoops. That's what happens when you slip. So minus 16 volts on 1 and 8 plus 16 volts on the other. So input pin 3, 1, 2, 3 is the one we're not getting any input on, and that's reading 0 volts, and the other one that we are getting inputs on, pin 5, that's pin 5 there, and again 0 volts. Okay, so now it's time to have a little look at the old oscilloscope. So we're not getting any volts. We could have a look at the inverting inputs, couldn't we, just to see if there's a difference in voltage. Well, actually pin 1 is the output. Perhaps look at the output voltages, of course. So pin 1 is the output from one side, which is 0.22, and the output is pin 7 on the other side, which is working, and that's 0.3 minus 0.3 minus 0.2. Very slightly different, but nothing drastic on there. Let's have a look again. The inverting input pin 6, which is 0, and the other inverting input, which is pin 2, that's 0 volts, and that's 0.0167. Come back to 2 again. 0.0000. There's a lot less on pin 2 there, which is the faulty channel. So I'm wondering whether this IC has bit the dust in some way. What do you think? Just go back again to pin 3, and that's 0.00012, and the other one was 5, 3 and 5, 4, 5, 0.00167, 6. Oh, hang on, did I measure that right? So the inverting input on the DUF channel is pin 2 is 0, and the input on pin 6, which is the working channel, 876. Five is the input. Is that chip getting warm? It's not getting warm. Not particularly sure what's going on here, but anyway, let's have a look at the signal. We obviously got our test signal going in. Let's have a look at the input signals going into that amplifier. Yeah, so the input to the board is these 2 pins. So that's one channel, and that's the other channel. So we're definitely getting an input to the board on both channels. Let's just turn the volume up on the phone. Turn the volume down on the amplifier. So there's obviously a fair bit of noise on there, but the point is we're getting a signal on both inputs. Right, so to pin 5, which is the working input, we're getting that, and then pin 3 is the other input, nothing. Come back to there, pin 5. Okay. let's just pause that a minute. Come back to here and let's have a look at here. So just to make life a little bit, so we've got input on these two inputs roughly the same, left and right inputs on pins 3 and 5 of that. Follow the black lines up, one channel goes through that capacitor there, C302, R304 and into pin 5. That we know is okay because we're getting a waveform there. And the other one comes up here, follow the black line up, folding the paper presumably, goes through here, C301, R303 to pin 3, and we're not getting anything in there. I would guess, hopefully that's just a poor print. Yeah, there's the line. Zoom out. Right, so presumably we've got to find C301. Let's have a little look at that. Can we see C301 on the top of the board? So C301, which is that one, is one electrolytic, and the other one's going to be C301 is actually the one we want. Now because it's, oh there it is, we can actually just get to the other side of it. Let's start the sound. Turn the volume down a little bit there. So there's C301, one side of it. Can we bring the scope in as well? Right, so there's C301, one side of it. There's C301 to the side of it. So that's on to pin 3. I thought pin 3 was the bad channel. Just go to pin 3, 1, 2, 3. And there's nothing there. Ah, but we have got a 1K resistor in between. Now the other capacitor on the other good working channel is C302. Ah, that's just over here, look. So let's just have a look at that. That's one side. That's the other side. So just compare the two again. One side, to the side. So the signal must be getting as far as those two capacitors, but it's not getting to pin 3, but it is getting to pin 5. So what have we got in between there? We've got C301, where we were. We've got signal on both sides, but we've got no signal at pin 3. So we've got a 1K resistor. Well, a 1K resistor could be open circuit, couldn't it? But there's also two capacitors, C307, that goes to the pin 2, the feedback, and then we've got C305, which is 100 puff down to, is that ground? Yes, that's ground, isn't it? So could we have a short circuit 100 puff capacitor? Oh dear, that would be a pretty much rarity, wouldn't it? The customer said it was working one day and wasn't the next. Is it feasible that the customer stuffed a signal in there that he shouldn't have done? So the simple answer really, if we measure resistance to ground, pin 3 and pin 5. So to pin 5, which is a good working channel we've got, to ground we've got open circuit. Are we actually owners working? Yep. And then to pin 3, 1, 2, 3. We've got 0.5 of an ohm. Just go back that again, pin 5, which is the other input. It looks like we have got a short circuit capacitor. C305. Now, one thing I've noticed on these capacitors, I'm just looking. See, these capacitors got they're like two-toned, and they've got like almost like they've got a dust at the bottom side of things, or they're warm at. I'm not sure. So let's just take our meter and put it straight across that capacitor if we can find it. C305, is it going to be? That's 303. I'll put my glasses on again because I can't see, being so old. C305, that's the one we want, isn't it? C305. So I'll put my meter across that capacitor. Yep, look at that, dead short. Well, I'll be. Right, so to show you what we had in terms of getting at these amplifiers, let's turn it on its side and then remove these screws. Right, now as I said, these should be fairly easy. You just had a little bit careful because obviously you've got wires hanging around, but I know for a fact that you can generally just pick up that whole amplifier stage with a little bit of jiggling, to quote Arkwright, and just get the board out. You've got a little bit of plastic that sticks out from the front there. It's part of a little clip. That's for this inner, because the front panel is made up of a metal bit and then a plastic bit on the inside, so that's what this clip is there. In fact, there's 4 of them along there. Just got to negotiate that little clip slightly and the board should flip over. Now if you're going to work on it live, you'd obviously have to put some form of insulation in there, but as we're not working on it live, in fact I will make sure it's completely live, non-live, by taking that off, and we'll find that capacitor that we found, which is that one there. There's no markings on the underside of it, unfortunately. There's R305. But that's it there. I think it's across those 2 pins there. Just bring the close-up camera in and show you. So I think it's these 2 here. So let's go across it with the meter again just to double check. So I'm pretty sure it's that's one input. Yeah, that's it. It's those 2 there. Yeah, it's definitely short circuit. As with all components that go faulty, if you heat them up, it's quite possible that heating it up can cure the fault. Now, like I said, it's just so weird to have one of these little capacitors go faulty. Such a rarity. Let's go on there. Let's get hold of that capacitor leg with, yeah. So right, so just get it and pull it. So there we are. Now I've pulled that back, the edge of the capacitor whilst pulling it out. Can you see that? Let's test it again. Now we've got it out of circuit. And it's no longer short circuit. Was it ever short circuit? Perhaps there's a short on the board. No. So worst case scenario is that, well, best case scenario is the capacitor is, the fault has cleared. It's a 101. Let's get the old component tester on it. And as somebody said in one of the comments on one of my previous amp repairs, the switch on this is in the wrong place. Well, the switch used to be up and down. I've now turned it 90 degrees, so it now goes sideways, so it works a lot easier. So we turn it on. Testing. And it says it's a 91 microfarad, 91 picofarad. So it's nearly 100 picofarad. So the fault has cleared itself. Well, I can only assume that. Why that one? I mean, there's no current flowing through that. Why would that fail? Doesn't make sense. Let me see if I can find a 101 capacitor. There we are, 101. I knew I had some somewhere. Let's just double check that. Yeah, near enough. So can't see there's going to be a lot of difference in it. The right value. There's no volts floating around there. Let's just pop that back in there. So we'll just clean off the legs. Run my pliers up and down there. Clean off the legs a bit. A little bit of clean off of the board, get rid of the little flux. I'm just going to let that just hang there for a minute. Power on. I can hear sound from both sides. Hey. So pin 1, 2, 3. Oh, you can't see it. Let's turn the scope on, then you'll be able to see it. Come on, mouse. Yep. And 5. Yep. I can hear the sound. So we fixed the fault that it came in for. Let's tell you what, let's have something other than a 1 kilohertz test tone. Okay, so that's working nicely. Apart from this volume control, let's do a little bit of a tidy up here for a second or so. Going back to wide cam. Let's just go down to the close-up cam because I want you to see what's right. So as I turn the volume control up, so I'm still turning it. See, it didn't. I'm turning it. Whilst it's working, it's working. Need a dedicated remote for that. Let me just get another remote. Right, so I've got the remote for the unit, so it's going up nice and smoothly and down nice and smoothly, but the rotator it's not. I know this should be moving a lot smoother than that. I think the fault is with this encoder, so let's have a little look inside this encoder. Let's power it off for a minute. So it's a good job we've got this board out so we can get at that encoder. Can we get at it where it sits? Okay, I think we can actually, because again, from memory, I'm pretty sure if we look at this in close up, you can see that there's a connector there that connects on this wire, and then the actual encoder is there, but we can take that off of the front panel separately. I don't think we need to remove the whole front panel off of it at all. I'm pretty sure we can do it that way. So let's just go back to the wide camera. I can get it out. I'm pretty sure if we just get hold of that knob, yep, and then a pair of pliers to undo the nut. And maybe we may have to remove this whole. That's loose. It's actually coming loose quite well. Yep, that's good. So there's the encoder separately. Okay, so there's the encoder. It's got a little bit of looseness there. I think we can actually dismantle this encoder. Bring it across that way so it's a bit more in the middle. Quite simply by releasing these tabs, just pushing them back slightly. So then the actual rotary part should come away. Yes, it does. So there's the encoder, and there's the connectors. So let's zoom in. So what we've got then is the wipers there and this one there, and as that goes round, so that's making little contacts up and down, but you can see there's quite a bit of gunk in there. So I'm pretty sure that with a bit of dubious cleaning with a toothbrush and isopropyl alcohol, we can bring it back to life. Let's do that and then give it a clean off with yeah, look at that. So to all intents and purposes, just a different form of volume control, working on pulses rather than actual controlling the varying resistance like the old type volume controls did. It's a digital control as opposed to an analog control. God, what a mess coming off there. Let's get another. Okay, I'll just brush across the wipers, being careful not to snag it and bend it, and that one as well. But we will just lever the wipers up just slightly, just to give it a much more definite contact. Same with that one as well. Like so. And then we can reassemble, giving that a push down. Like so. Let's just get a pair of pliers just to squeeze them together a little bit, and then just clamp them down a little bit. Just caught that one. Just make sure it turns. Yeah. Okay, pop it back into the front. Now let's just fold that amplifier back and there again. I won't lock it in place for a minute. Let's go to the next track. That'll do, something different. Go close up. That's better, isn't it? No more stuttering, it's going up and down just as we want it to. Perfect. So there we are, another final repair. So all we've got to do is to remount that back in, put the lid on, send it back to the customer. We're done. Thanks very much for watching. Hope you've enjoyed this video. See you on the next one. Bye for now.